Hello, and welcome to the world of Fun with Statistics with Dr. David Bugg. I am here to talk to you today about nonparametric tests of significance. This is lesson 9 in Stat 100, Statistics and Probability. So, today, as we talk about nonparametric tests of significance, we've been learning recently in class about what we call parametric tests. Parametric tests are when we have tests of statistical significance that examine dependent variables of interval and ratio level measures. You may have been asking yourselves the question, but Dr. Bugg, what do we do when we have data that is not a dependent variable at an interval ratio level? Well, in the case of conducting a test on a dependent variable with nominal or ordinal level data, we use nonparametric tests of significance. We can also use this when we have skewed distributions, as noted in slide 2 of presentation 9. The problem with this, though, is that we have a weaker test. And so we talk about the power of a test. What is the power of a statistic to reject the null hypothesis when it is actually false and should be rejected? Now, we have talked about type 1 error and type 2 error in previous lessons. Now, nonparametric tests are weaker statistical tests than things such as the t-test and ANOVA. So nonparametric tests aren't always preferred in research scenarios because they are a weaker test. But unfortunately, sometimes they have to be used. The more powerful a test is, the more requirements it has. And nonparametric tests have fewer requirements than things such as t-test and ANOVA. We're going to focus on a particular kind of nonparametric test known as the chi-square test. Chi-square test is when we are testing two different groups and we want to, two or more different groups, and we want to examine a nominal level variable. And so chi-square tests come in a variety of forms, one of which is the one-way chi-square test, which we use when we are making a comparison between the observation we have made and the expectation we have about a situation. This comparison allows us to see if the difference is statistically significant or occurs purely by random chance. If you refer to slide 4 in presentation 9, you can see the formula for a one-way chi-square test. And you can see there that we have observed frequencies that we compare to expected frequencies for any category. And this is used in a variety of situations. However, in sociology, for example, where we're interested in comparisons of two observed groups, we use a two-way chi-square test. So we make a comparison between two groups, and the two-way chi-square test is used to determine whether one observed frequency for a group is significantly different than the observed frequency for a second group. Now, in t-tests and ANOVA, we were using means to make group comparisons in hypothesis testing. Unfortunately, with dependent variables at the nominal level, we must use frequency counts because we can't calculate accurate means, and since all we can do is do a count of each category, then those frequency counts will serve as our purposes for comparison. The two-way chi-square test is preferred in sociology because it allows for direct comparisons between groups, as opposed to comparisons with a hypothetical observation, as is done in a one-way chi-square test. Now, when we are conducting a two-way chi-square test, if you refer to slide 7 of presentation 9, you will see that the requirements for a two-way chi-square test are as follows. A comparison between two or more samples is required, so we need at least two categories or more in our independent variable. We need nominal level data for our dependent variable, random sampling, and our expected cell frequencies, that is the frequency count for each category of the independent variable and the dependent variable combined, should not be too small. What does too small mean? Well, a too small frequency count is typically anything less than 5, in which case we would need to correct for the small frequency count, and we do this through something known as a Yates correction. And so that is one form of nonparametric test. Another form of nonparametric test is the median test. Median test was designed for use with ordinal level data when we're comparing two groups. In the median test, obviously as the name implies, we calculate medians and compare them. The requirements for the median test are two or more medians, so we need two or more categories in our independent variable. Our dependent variable needs to be ordinal level data, and random sampling. These two nonparametric tests are quite common in hypothesis testing. Although the median test is not used as frequently, chi-square tests are used routinely by researchers. That's all for now. Be sure to tune in for more fun with statistics. I'm Dr. David Bugg, signing off. If I can find my off button.